So if you look at this point, what we are going to get at this point is if you look at this point, we are getting the current through this side is Is, and this current is getting divided into two parts. One part is Iz and another part is IL. So I can say Is it is equal to Iz plus IL. Now since the input voltage is constant, so this Is is constant. Is is constant. Is is constant, and load resistance is decreasing. Load resistance is decreasing. That means we have to make output voltage constant because the output of the Zener diode should be a regulated voltage. So voltage should remain constant. So in order to maintain the voltage constant, the current IL has to increase. So if suppose IL will increase, that is going to decrease the value of IZ. IZ value will decrease. Okay, so the current through Zener diode will decrease, and if suppose the current through Zener diode it decreases, but the constant supply current is coming at this point. So if IZ value decreases, that means more amount of current will be passing through the I RL. Okay, and such that the voltage across the Zener diode it will be same as the output voltage, and it will be equal to IL into RL. Okay, so this is the second case in which we can say that the output voltage is constant, input voltage is also constant, but the load resistance it is decreasing because of certain reasons. Okay, so this is the one of the case B. Let us move to the case C. The case C is what is going to happen when there is no load in the circuit. So no load in the circuit, that means this is an open circuit. There is no load in the circuit. So if suppose there is no load in the circuit, that means the circuit is up to this much only. This part of the circuit is not present. This part of the circuit is not present. So if this part of the circuit is not present, what I can say, whatever is the value of Is, the same current is flowing through this Zener diode. So the same current is flowing through the Zener diode. So when there is no load in the circuit, the load current will become zero. So load current will become zero. That means all the current. What was the value of Is? Is value was equal to Iz plus IL. So whenever no load is there, so that means this value is zero. If this value is not there, that means Is it is equal to Iz. That means whatever is the current Is, it is same as the value of Iz. So all current passes through what? All circuit current passes through a Zener diode. So all circuit current passes through the Zener diode, but there is a limitation of the Zener diode. The limitation of the Zener diode is, what are the specification of the Zener diode? The value of Vz, the value of Iz minimum, the value of Iz maximum. These are the three main specification of the Zener diode. In order to make the Zener diode to operate in this as a regulated voltage, operate the Zener diode as a regulated voltage, we should consider the current rating between minimum and maximum Iz value. Okay, so whenever it is crossing this Iz maximum, the current through the Zener diode it is more than the Iz maximum, so that will make that will damage the Zener diode. Okay, so that is going to damage the Zener diode. That's why we will select the value of RS. So RS value, why it is included RS value? RS value is included in order to minimize the current through the Zener diode in the case where there can be a situation that load is not present. So if load is not present, there should be the value of RS which will limit the current, and that will make the current to the Zener diode not exceeding this Iz maximum value. Okay, so the current through the Zener diode will be lesser than the value of Iz maximum because of this value of RS. So RS should be selected in such a way that the current through the Zener diode it is limited to the maximum value of the Zener diode. If it is exceeding the maximum value of the Zener diode is going to get damaged. Okay, so this is the case C of the Zener diode, right? So let us move to the working of the Zener diode. So what is the working of the Zener diode? So again, the same cases we are going to see, but we will see with respect to some equations. So the case A, if the input voltage increases. So what is the value of this V in? So whatever is the value of V in, this value of V in, it is equal to the value of Vs plus the value of Vz. Okay, and Vz and Vo both are what same. Vz and Vo both are what same. Vz and Vo both are same. Now this value it is constant. This value is not going to change. This value it is constant. This value is not going to change, right? So what is the value of this V in input side? Input side I can say the current through the input side is what Is. Is is the current through the input side. So this is the value Is into Rs. So what is the value of Vs? Vs it is equal to Is into Rs. Okay, plus the value of Vz, plus the value of Vz, right? Or you can say it is Vz, it is nothing but Vo. So you can also write like this. So this is equal to Is Rs plus Iz, you can say it is equal to Vo, Iz which is equal to Vo, and Vo value it is equal to the current through this is IL into RL. So this is what IL into RL. So you can also write like this. So whatever is the input voltage, okay, this is the value. This is the value. So if the input voltage increases, if the input voltage increases, what is going to happen? Input voltage increases. So input voltage it is increasing. So if input voltage increases, the value of Is will increase. The value of Is will increase. Now Is it is divided into two parts. In this case, Is it is equal to Iz plus IL. So if Is it is increasing, so which part it will make increase? It will make Iz increase, but this IL will remain constant. This IL will remain constant. So if suppose this Is it is increasing, it will increase the value of Iz. So Iz value will increase, but IL value will remain constant. So in this case, IL value is constant. IL value is constant. That means IL into RL. RL is what constant. IL into RL, this value will remain constant. And IL into RL, this value is nothing but VO, and VO value is nothing but VZ. So what we are getting in the last, VO it is constant. So in the last we should say that VO it is constant, right? Okay, so this was all about the case A. Let us now, you can pause the video, you can write the things down, okay? I'm moving to the next part B, case B. Again, the same thing, but we are going to learn in the equation format. When the input voltage is constant, but the load resistance RL it is decreasing. So if suppose RL it is decreasing, so what is going to happen? Again, the same equation we will write V in it is equal to Vs plus Vz, or Vz you can say it is Vo, and that is the ILRL, and that value will remain constant. So the current through the current through RL it is IL, and the current through Zener diode it is IZ. So at this point, if suppose I consider the current, so incoming current is equal to outgoing current. Incoming current is equal to outgoing current. So what is the incoming current? It is Is. So Is it is equal to outgoing current, which is Iz plus IL. Remember, the aim is to maintain this Vz constant. The aim is to maintain this Vz constant. Okay. So if V in is constant, V in is constant. So V in is not changing. V in it is equal to, what is this value? It is what? Is Rs. Vs value it is equal to Is into Rs. As per the Ohm's law, V is equal to IR. So I can say Vs it is equal to Is Rs plus Vz. Okay, plus Vz. This Vz you can say it is nothing but equal to Vo. Okay, so in the next step you can write this Vo, it is nothing but your ILRL. So this is ILRL. Okay, now in this case this term is constant. This term is constant. So since this term is constant, this Is is the source current. So current through the source is also constant because source itself is constant. So this part is constant. So what is happening here? This part it is decreasing. So if this part is decreasing, what is going to happen to the IL value? In order to maintain this part constant, this part also constant, in order to maintain this part constant, this IL it will increase. Okay, for example, if suppose RL it is decreasing by 2, so RL by 2, so this IL it will increase by 2. Okay, so it will become double by a factor of 2, sorry. So RL it is decreasing by a factor of 2, IL will be increasing by a factor of 2. So for example, what was the value of IL into RL? It was equal to VO or VZ. So what is the value of now? IZ IL dash into RL dash, it is equal to IL dash, it is 2 times IL, and RL dash it is RL divided by 2. So RL, see here, RL it is decreasing, it is getting RL divided by 2. So proportionally IL value it is increasing, it is what, 2I. So 2 value will get cancelled. What is the value we are getting is RL IL RL, right? So IL RL it is nothing but same VO. So here you can see that VO and here VO both are what, same. VO and VO both are same. So this is example. Okay, this is just an example, right? So if it RL it is decreasing, it has to increase the value of IL. Okay, so IL value will increase. So how IL value will increase? We have the decrease in the current or increase in the current in the value of IZ only. Okay, so we are having IS, it is equal to IZ plus IL. Okay, so how this IL value will increase? If suppose IZ value will decrease, then only IL value will increase, because IS value, this is what, constant, because source is constant, the current through the source will be constant. So the current through the Zener diode will automatically decrease in order to maintain the value of Vz constant. Okay, so by this, by this, the Zener diode will supply the regulated voltage to the output side. Okay, you can pause the video, you can write the things. I am moving to the next case. So next case is case C. Case C says that if there is no load in the circuit, the load current will be zero, right? So if suppose this part is not there in the circuit, so the circuit it is up to this much only. I can draw the circuit like this. So this is plus or minus V in. So V in it is what, unregulated input. So this is unregulated input, unregulated input. So this case will not arise practically. Okay, so what we are supposed to do, we are supposed to protect this Zener diode from getting damaged. Okay, so because nothing is there, that means total current it will be flowing to the circuit, the IZ value it will be equal to IS value. See here, IS is the current in this branch and the current in this branch is IZ. So IZ and IS both values will be same. So this is the value of RS, right? So what is the input voltage here? Input voltage V in, it is nothing but Vs plus I can say Vz. Okay. So why we are applying this resistance Rs? Because if suppose we apply direct voltage, we apply direct voltage V in. Okay, so V in, suppose it is 30 volts. Okay, and Vz it is, suppose you can say it is for 20 volts. So 30 volts it will be directly connected to 20 volts Zener diode, and this will damage the Zener diode, because if suppose Rs is not present, I am removing this Rs. Suppose RS is not present, so that means V in and this IZ, they are just connected side by side. Okay, so whatever is the voltage of this V in, same should be the voltage of VZ. So the voltage, the Zener diode voltage, it will cross the limit. Okay, it will cross, it will become 30 volts, it will cross the 20 volt, and the corresponding Zener diode it will damage, right? So what we are doing, so we are applying a resistor over here. So this is the source resistance. What this will do, it will introduce the new voltage Vs. So it will drop 10 volts across it. Okay, so this Rs will drop 10 volts across it, such that this will protect this Zener diode for going towards this 30 volts. Okay, so the value of RS should be selected in such a way that in the case of no load condition, there it should drop that much voltage. The V in maximum V in voltage, it should drop by some amount such that VZ maximum will not cross. How VZ maximum will cross? VZ actually it is equal to IZ into RZ. What is RZ? There will be some resistance of this Zener diode also. Okay, so practically it is not a straight line. Practically it is not a straight line. Practically it is some slope, right? And this is the value of Vz. So this is what the slope will be. Will give you the value of Rz. Okay, so there will be some slope, right? So I hope you are understanding the thing. So this case it is it explain you how why this source resistance has to be there in the circuit. Okay, so this I have explained you with a particular example. Okay, so this is just an example. So if suppose Vs is not there, V in all is always V in is what fluctuating like this, right? V in it is fluctuating like this. So this is V in, and what is Vz? Vz it is a straight line. So you can say that always this V in it has some maximum value. So this is the maximum value of V in. Okay. So if suppose the Zener diode goes up to this value, so it will get damaged. Okay. So what we are going to use? We are going to use is the source resistance. The source resistance will protect the voltage of the Zener diode from moving towards this value. It will maintain it will absorb this much rise in the voltage, and it will supply a constant voltage or constant current through the Zener diode. It will be the maximum. It will be somewhat lesser than the IZ maximum value. Okay, so this is all about the case 3. Case C, you are requested to pause the video. You can write the things. Okay, so what are the applications of Zener diode? So this completes the Zener diode explanation. So what are the applications? Application means where the Zener diode is used. So Zener diode, the main purpose of the Zener diode is it is used to get a constant voltage. So Zener diode is used when the constant voltage is required. The Zener diode is always connected in parallel, and also always it is connected in reverse bias condition. This points you should remember. So there should be 3 points to be remembered in the case of Zener diode. First, it is used as a voltage regulator. Voltage regulator means it is used to get a constant voltage. The second point to be noted as it should be applied in the reverse bias condition. The third point is the Zener diode is always connected in parallel. It is always connected in parallel to the load resistance. Okay. So what is next? It has the number of applications. So it has a number of applications. Just in the rectifier circuit only it is not used. So where the Zener diodes are used, the first one is what, a voltage regulator. We have already studied the voltage regulator. The second one is fixed reference voltage provider in transistor biasing circuits. So if suppose in any circuit, if suppose you want a constant voltage, a reference line of a constant voltage. So we want a reference line of a constant voltage. So what we can use, a Zener diode we can use of that particular voltage. Suppose that constant voltage is V. So I can use a Zener diode of voltage V. So Zener diode voltage will be equal to V. Okay. So if suppose I use this type of scenario, I can provide a constant voltage to any given application or any given component of the electronic circuit. Okay. So here it is used to give a fixed reference voltage provided in transistor biasing circuits. The next is peak clipper or limiter in the wave shaping circuit. So for example, a wave shaping circuit, for example, this is what a wave of 2 volts, but I require a wave of 20 volts. So I will be using a wave shaping circuit. I will shape this wave, I will reshape this wave, and I will get what, a 20-volt wave like this. So this is a 20 volts wave. Okay. So what I want is we want 20 voltage only. So if suppose the wave it is crossing the 20 volt, I should not get that wave to cross the 20 volt. Why? Because it may damage my circuit. Okay. So So I will use a Zener diode which is of 20 voltage. So whenever, if suppose there is a situation that the wave it is crossing 20 volts, if there's a situation that the wave is crossing 20 volts, so it will clip that 20 volts. So this is what the situation where the wave is, it is present at suppose 25 volts. Okay, but we are using a Zener diode as a peak clipper. So whenever we get 20 volt, so it is going to clip it. Clip it means it is not going to increase further, and it will maintain that voltage. So what our output waveform will look like? The output waveform will look like this. Not only in the positive direction, it will be same in the negative direction like this. So this is what the peak clipper output it will be looking like. Okay, so black one is the output of clipper, or we can say limiter in the wave shaping circuit, right? All of you are requested to pause the video, you can write the things. Okay, next, it is used for protector against meter damage. So whenever there can be a situation that if suppose a voltage is greater, okay, voltage is increasing, and if it is increasing drastically from accidental fluctuations. So from accidental fluctuations, if suppose the voltage is increasing to a very peak value, so this Zener diode it can be used as a protector. So in order to prevent damage of any other circuits, the Zener diodes can be used as a protector. But we should always, in order to get this application, we should always think that the IZ maximum value should not increase. Should not increase. IZ value should not increase with the IZ maximum value. Should not increase than Iz maximum value. So if suppose Iz value increases beyond Iz maximum value, then it will damage the Zener diode itself. So Zener diode which was used for protecting the circuits itself will get damaged. Okay, so we should be very much careful while selecting a Zener diode, while selecting the Iz maximum value, and we should be very much confident that the circuit current will not exceed the IZ maximum value. Okay, so this was all about the application of a special purpose Zener diode. So in the next topic, we are going to learn about the photodiode, that is also a special purpose PN junction diode. So Zener diode, we understood that it is specially doped. It is very heavily doped compared to the PN junction, normal PN junction diode, such that if suppose we connect it into the reverse bias condition, it can be used as a voltage regulator. It will give you the constant voltage Vz across the load resistance by increasing or decreasing the current flowing through the Zener diode itself. Okay, thank you so much, all of you, for paying attention. Take care. Goodbye.